my sort of goal and dream is to create a network of individuals that don't have high overhead so we can be really nimble and cost effective. And I think that's the way where we can kind of have the biggest impact as ecological designers and implementers.
So when you design these systems, you have a certain number of plants or acreage of plants or something like that, which requires a certain amount of water to keep them going, right?
No.
They don't?
Those are in wastewater. So that's just, they're just in the wastewater that's flowing through them.
Well, that's what I meant. I
Yeah.
mean, there's a flow of wastewater going
Yes.
through the system,
Yeah.
which keeps the plants. So,
Right, but if the wastewater stops, then you just stop discharging it and it just maintains. So you're never using makeup water in that particular situation.
so when you have a certain requirement that here's your base flow, and then you have like a big rain or something like that, how much extra flow can those plants take, or does it just go through?
It just goes through. And so, and basically the retention times are based on high rain episodes. And so during regular operations, they're having 3 to 4 times the retention times that they require than in a big flow on. And in that particular case with Limonera, their lagoons were so big, we had so much retention time anyway. But basically the flow restrictions isn't on the plants, it's on the pipe sizes and pumps that you have moving it through. And yeah, it's the hard structure, infrastructure, not the plants, because even if the plants did get overwhelmed, they would just treat slightly less well, but in a high rain event, you're gonna have more dilute anyway, so it kind of offsets.
And so are you using the hydro pressure to recirculate even the vertical part of that, or how are you?
No, yeah, that's just by displacement, the vertical part, but then the recycle and the discharge, we're using 110 pumps or 220 pumps, yeah. I haven't figured my way around that one yet. And that's just before and after, and that picture's a few years old. The after water is even better now. It's really close to, in terms of bacterial counts, nitrogen, total suspended solids, it'd be close to, if you didn't know it was treated wastewater, to medium municipal drinking water. And this is a system here, and this is a kind of one of these more resorty ones, but what the conventional engineering group wanted to do, because David Robinson of the San Antonio Spurs owned that house up there and doesn't like algae, looking down on the 5th hole of the golf course, right? So the conventional engineering solution was to take a 60 horsepower pump and suck water out of the aquifer, then take a 45 horsepower pump and deep inject it. And so that's 100 horsepower to keep a pond algae free. So we said, we think we can do better. What we did is we built a gravel filter around the periphery of it that we then airlifted up to our restorers in the middle of the pond, and we were able to maintain that same kind of Hawaiian lagoon look instead of 100 horsepower, 2.5. And again, with many of these biological systems, because they're living things like horses, cattle, ourselves, the steward of them has a profound impact. And so David Chai was one of the great stewards that we've ever got a chance to work with. And so he looked down and he saw how effective it was. He goes, well, he was an aquaculturalist too. And so he's like, I'll grow fish in there, and then shrimp, and then oysters. And so then he started providing the restaurant with it. And so it says here, when a chef at the Four Seasons Wailea needs a fish or a shrimp for a dish, a fresh supply is available at the 5th hole of the golf course. And we got that EPA for business and the environment. Okay, so this part here, it says, this pond saves energy costs for the Four Seasons. If we set up another area as a fish pond, without this system, it costs close to $10,000 a month in power. This one runs about $400. And so these are schematics. So one of the products I've been using, and I'm not plugging them. I do like the product quite a bit. I don't like to be penned in by one, and we still know how to make our own restorers, but there's a company called Floating Island that's off the shelf. So if you want to buy it and put it in a farm pond or whatever, they're fairly expensive, but they're also very effective. And so they're just a matrix for growing, and these are their biohaven floating wetlands. And that's their schematic view. And that's some more of their images there, just doing passive remediation. And when we get to some of the, what I call fake lakes, the Hollywood lakes that I've been working on lately, like this one, is I just find that the floating islands themselves weren't enough. And again, I turned to aeration to circulate the water and to destratify, de-eutrify the water column, but also that half horsepower blower right there circulates 12.5 million gallons per day. And so you're able to get that over the beneficial surface area. When there's 3 of these islands and 3 of these diffusers in there, I put them in January 2017. They were barely maintaining fish populations because of an outbreak of something called golden algae, which is a microscopic algae which gets in the fish gills and kills them. And so then the pond management company was controlling the golden algae and keeping most of the fish alive, but they weren't biting and they were really unhealthy using copper sulfate, which is, it's going to be a legacy pollutant. And maybe this doesn't appear looking at that like the noblest ecological work, but we were able to stop putting chemicals into this pond and lake and to get the fish populations back and make a living, which was one of the really important parts to me at that part of 2017. And because this was so successful, a lot of the lakes that are either unable to maintain fish populations are now coming to us, and we're able to get chemical management out of the lakes of Orange County. Not to refer back to the bad financial times, but I had some scraps over at the Limonare project, and I was able to convince them to pay me to reshape the scraps and plant them for East Lake there. So the plants are a year older now, and the whole system is completely mature, and it looks really good. So this is the 3 aerators, and the idea with this one was to create a pilot, because my first proposal, they're like, no, that's too much money, was to create a pilot where the fish, and a zone where the fish could come if there was a golden algae outbreak. But because this lake was minimally but mechanically circulated, the pilot ended up treating the whole 15-acre lake. So these 3 islands and these 3 diffusers ended up treating the whole lake, and now the whole lake is completely clear. The fish population is completely vitalized, reproducing. They're big, they're biting on lines, and you can see the fish and the bottom throughout the lake, except when it's raining, and then in August when the algae really gets a toehold. But there you can see, I know the lighting is different, but you can see the day I put it in, January 2017, and then that was last May or April. And just the difference in the water, and when you're on the lake too, the smell is gone. And the main indicator, of course, is just the fish are happy, aggressive, and reproducing. And so they were having a bit of a crisis because the people who'd bought houses on the fake lake for fishing were getting ready to sell their houses, and so that would create a little dip in the real estate. So this was a very cost-effective way of offsetting that real estate crisis. And this is when I get like the guy with the big purse strings. This is what I'm going to build. Or a municipality. I'd love to do this in a municipality, just to have this. But what I'd love to do is a big urban public space that in an impaired piece of water that you could then watch it improve over years. So maybe like a bad urban area with a little water feature and revitalizing it using a technology like this. This sketch was by my friend who worked for Ocean Arcs for years called Ian Ambler. Give him a plug.
Are these man-made lakes or are they stream-fed?
The ones that you saw in California, man-made.
Is there a difference as to what you're dealing with?
Every lake, there's so many different variables. Like I'm also doing stream-fed lakes and stormwater-fed lakes, and it's just different problems. A lot of these closed lakes that are better designed, but then you get fungicides, herbicides, lawn nutrients going in, and what with the fires came with a couple blocks of where I live, but with the fires now on some of the arroyo-fed lakes, you're just getting so much debris in right now that we're suffocating in debris. So it's different sets of challenges in every lake. There's nothing uniform about really anything to do. The TDS varies, the total dissolved solids, the salinity. And so the one thing we know that is beneficial to come back is to move the water and to create healthy ecologies in the lake. And a lot of this goes back to with the ocean restorer, underneath these things you can have the algal turf communities, you can have all of these different things. And so to create healthy ecologies and move water through them is what we quantify ourselves as doing. And then we're now working with a scientist who actually got his PhD in Woods Hole, but he's living out there. We're both what we call deer tick refugees. We just got tired of getting Lyme disease and moved out to the birds and it was dry. He thought we were claiming that we just uptook all the nutrients in the pond and started out the golden algae, and when I explained to him that we're just creating ecological pathways and we're not making claims of nutrient removal, he got much more open to it. Before he was advocating the way that we're the only solution out there that does no harm, and now he's seeing the good that this approach is working for these lakes. And the harmful algae blooms are just ubiquitous throughout the West, whether it's cyanobacteria killing dogs or golden algae killing fish. It's getting to be a problem as salinity is going up because of climate change. Runoff is going up because bad management continues. So even though these lakes aren't maybe the most noble work, they're a good practice run for some bigger problems.
And so with all of these, are you incorporating best management practice for runoff, or, because that...
We don't always have that control. I mean, we might just be given, sometimes we get to go upstream, which is really nice, but most of the time we don't get a chance to go upstream. We just get it where we get it. And it would be great to go upstream. I mean, obviously, ultimate solution is to eliminate by going upstream, sort of like we talk about, like we'll go to the pond today, and we'll employ best management practices so none of that gets to downstream from our pond, and we'll kind of harvest things upstream from the pond and everything like that. And I think opportunities like Living Web and our pond here are to create the prototype for going upstream. And to really duplicate upstream is to create the economic and both the data set that you need in order to quantify it and to convince city officials and engineers, who are generally pains in the ass because if they don't know something, then it's not correct. And then the economic model for doing that. And I hadn't really, I hadn't paid as much attention to my father's sort of the Second Homestead Act, and I think that's huge, and also urban revitalization and all those opportunities. But I think you actually have to put a monetary value in our culture to be able to duplicate it with any success. It's never about the technological challenge of getting it done. It's about the political and economic challenges, really.
Just some curiosity. I read a few years ago that Lake Titicaca was having some bad problems with too much algae, too much eutrophication, nutrients getting in, and the smell was bad, and bad for tourism and all that. And they did nothing more than bring in some effective microorganisms, EMs, and then they started, like manufacturing a bunch of that for periodic applications, and it did the job. So I'm just curious, is that a technology that is adequate for some of these tasks, or? Sure,
yeah. I mean, most lakes don't have enough mixing. So if you just put in microorganisms, they'll stay, or maybe over years they'll mix up. But if the lake is mixing itself anyway, if you're getting a turnover, or if it's mixed by, I think Lake Titicaca is mixed by wind, so it gets good mixing by wind. So then you can just seed and they'll go outward. But then again, if you were to put who was the gentleman who was telling me about a floating?
Kapok?
Kapok, yeah. So you can create, you could give the people of Lake Titicaca and they could create their own restorer floating islands, and then that would make that whole, beneficial microbe community have even more of a foothold. In just in the water column, we've found that it's less effective than if you give it a matrix, especially a symbiotic matrix that they can live in, and then they can slough off and sort of go out into the water column. If it worked in Titicaca, then it worked in Titicaca, and so it was probably by wind mixing and the right mix of microorganisms. And going back to John's presentation, we go to 12 plus different ecosystems. We're not selecting our bugs and our microorganisms in a lab. We're using a turkey baster in mud puddles and ponds to go after them.
Well, and you were talking about the bureaucracy behind all of it. How much do you guys go out and actually try to get governments to understand, or is it kind of people come to you?
Personally, I'm bureaucracy averse. I'm not the right person to ask about that. I'm too ornery for that. And this is just so 20 miles away from East Lake was Lago Santa Margarita, and they'd have no fish population left. And again, there's a big stink about it, and they have midges and smells. And so we put in 11 aeration discs and 22 little floating islands. For some reason, something that I'm inordinately proud of is the Coots, which are a Canadian immigrant group, come in and they just wipe these islands out of their plants because these are highly aesthetic. We're not using really robust natives like bulrushes and cattails. We're using pretty plants, but pretty plants with a good history and good root systems. But they were getting wiped out by the waterfowl, and so my invention of putting electric fences on floating islands has been really successful, and I'm inordinately proud of that for some dumb reason. This is just a system we put in to manage golf course runoff in Hawaii. And again, the reason I included this slide wasn't to brag that I was in Maui last month, But you see these baffles, so instead of having aeration, because the water traveled through here and we didn't really require it, we put in these baffles, which is that same geotextile fabric, and we stapled it to cable along here, and so it's going back and forth and it's baffling the water into the root systems of these floating islands, and they're all planted with native Hawaiian plants. And this is just underneath the lake at East Lake, and the footage is from a year ago, so the vegetation isn't what it is now. But yeah, those are fake plants. There's some very persnickety homeowners.
What is that?
That's the floating island up. That was a fake plant. Here you can see the fine bubble aeration pushing the water. So that's 12.5 million gallons a day per diffuser going through that, really powerful. And again, I go back to the tugboats, and I just think that horsepower kind of works. And then you see this happen again and again in these different situations. And again, it boggles my mind. That's a coot. They're no good. But it's funny, they were ready last January, they were going to tear these islands out even though they saw the benefit to the water, but they looked so bad because of the coots. And I tried putting PVC hoops over them and bird netting, but that looked too ugly for the homeowners. And so finally I was like, well, electric fence is the last thing. And I was like, can you ground an electric fence in water? It's like, of course you can. And so that's what we're doing now. It's now part and parcel for the installs. I think I might put a few slides at the end just for reference, but maybe this is the end. Oh yeah, so again, we're talking about intercepting the water before it becomes a liability. And in Los Angeles, 95% of the water that falls on the ground ends up going horizontal, becoming very dirty, running into the LA River and going out to sea, where it really does quite a bit of damage. And this is an area that's devastated by drought. So Surfrider, which is like a coastal preservation environmental organization, has a certification called Ocean Friendly Gardens, and this is one I got to install at Englewood City Hall. And this is during the installation process. So basically it takes the impervious surfaces around it, collects it, and it goes into these two bioswales, and it perks, even during these big rainstorms that we've been getting, it's perking everything that it gets. And there's one, this was designed by a landscape architect, which is why it's nice. And there's the one that I designed, which can handle 10,000 square feet of rainwater and coming down at it in a storm event. This one's capturing all the impervious surfaces and all of the lawn coming off. And then there's a bioswale trench along here, and then it diverts in a trench drain across to here and goes to both of these bioswales here. And it's working really effectively in this. And so I loved it, even though it was mostly just swinging a pickaxe and not making much money. It was a great opportunity because starting at Limonera, getting the water at the end point, and then being able to go up to the beginning point of the whole hydrological cycle in that area was a great opportunity. And I got to do 2 of these ocean-friendly gardens, and I'd love to do more of them.
So that's really cool because that's an application in all urban environments where there's so much cement.
Right, exactly. And people have been doing it in Portland for a long time, and just all over, but best management practices around stormwater are huge. They're usually really pretty. They're usually a landscape amendment. Here we created a park. This was lawn that was just completely unused. Now people are in there all the time. We created we were supposed to use the stumps from the pine tree that they'd cut down there, and I asked them if they knew what happened when you sat on a pine stump, and they didn't. So I told them, so we used eucalyptus instead of pine. But there's a lot of people doing this here. This is one of the nicer ones, but I didn't design it again, but me and my friend Jose Serna put it in, and it was just a couple of weeks of a lot of pickaxe work, and then we got to plant it, which is the nice part.
How big a team do you ever have on installation?
Again, I use a network of people from all over the country, but usually pretty small. So for this one, I use a local friend, and some of the bigger installations like Limonera, I brought about 5 guys out from the East Coast to do that. But we like to keep the crew small and the days long, and trying to less start and stop and a lot more trying to getting it done.
That's kind of what I was going to ask. How many landscape architects have you been able to work with locally in different areas to kind of educate them on?
Well, in this case, they were educating me. And so this were people who were working at harvesting rainwater in Los Angeles and also getting rainwater back. And the guy's name is I'll write it down at the end of the day on the whiteboard, and for some reason I'm drawing it. But he'd been doing it for a while. I'm also working with an architect out of Mexico City that does rainwater harvesting. It's not really necessarily us implementing, it's just like I have my own one-man band right now, and so I'm just trying to grab all these opportunities that come by. And this was an initiative done by the Los Angeles West Basin Municipal Water District, and they were just looking for bids, and nobody wanted to do them. And so I got the opportunity to do them. But it was more a construction project for us, and that just was really in alignment with what we wanted to do. Oh, that's just the swale during the construction phase. You can see it collecting water during a rain event. Oh, and this is actually a cool one. This I got from Conservation Design Forum, but I don't have the pre-slate, but it's a police station designed in the 60s, and it had 100% runoff. And then this is what they did to it to make it 0% runoff in a 5-year storm event. And so you can take a piece of horrible 1960s conventional infrastructure, architecture, parking. I mean, the problem with this country, and I'm part of it, is so much of our planning and our resources and everything go into accommodating our love of cars and our lack of willingness to go over to public transportation. And again, I'm as guilty as anyone, but this is a pretty interesting example of stormwater management. Oh, and this is, we just get waste to food stuff. This is so this was, we'll go through this real quickly and then we got to wrap up, but this was done at South Burlington by my friend Eric Wells, who's left us, and my pops, and a guy named Dave Demarest. But they were taking spent straw from Eric's chicken operation down at the Intervale. They were pasteurizing that and growing oyster mushrooms, and they were getting 16, so this was a waste. So this is a waste to value added sort of example. Then they were getting oyster mushrooms that they were getting $16.99, or it was a lot down at the city market in Burlington. And then they were taking that over to the worm dudes, and the worms were converting it into really high grade, worm castings, which you're all familiar with. The worms were feeding a fish supply, and then they were able to get 7 croppings of greens out in an unheated greenhouse in between November and March in that experiment. Then they were able to sell it for something like 3 times that of compost after they'd been using it. And so that was the, sort of waste to value added using ecological, or you guys would just call it farming practices. And that's a natural swimming pool.
I have one question, and don't make it go big, but with the nanotechnology that's coming out with using copper and all of that, is there any way to measure that, or are you finding that these plants seem to help with some of that? There's so much runoff from people doing decks and all kinds of stuff with
The plants definitely help, and again, biochar is a huge tool going in. I'm now mixing biochar into all of my soil mixes that's going into both gardens, but also the little plugs in the floating islands. I'm mixing biochar, worm castings, and then it's a combination of biochar, worm castings, mycorrhizal inoculation, and then I just use coconut coir because it wicks the water up. Any questions, or should we go see a pond?